The notes for today are going to start with parts of similar triangles. If two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. So the first one we're going to start with are altitudes. So if I look at this triangle here, remember the altitude goes from the vertex to the other side, and it's perpendicular. It's not a perpendicular bisector, it just needs to be perpendicular. And so I've got two triangles with altitudes in them. So when I have these altitudes, I can say that BD, my altitude here, is to FH, which is the altitude on the other triangle, and that is equal to AB, one of my sides here, over EF, one of the other sides. I can also say this is BD is to FH as, and I can use the other side. So I could say BC is to FG. Okay, the next one, we're going to use angle bisectors. And so angle bisectors means that these two angles are congruent here, which is what they're showing us. And so for this one, our proportion is going to be that angle bisector QS over UW is going to be equal to, and we'll have QP over UT. And we can also say QS over UW using those angle bisectors. And we can say QR over UV. All right, and then the last one, we're dealing with medians. And reminder, the medians come from the vertex to the other side of the triangle, and they are cutting it in half. It's bisecting it. So those two are congruent. So for the medians, we're going to say that our median, HJ, over LN is equal to, and we're going to grab one of the sides, GH, over LK. And then we can also say HJ over LN is equal to HI over LM. Okay, so let's go ahead and do a problem. We're going to set up proportions again, and we're going to solve for x. So for this first one here, it looks like I'm dealing with medians. So I'm going to say x is to 15, so x over 15 equals, and then I'm going to take one of the sides. So for this one, I want to kind of think through again, what's the side's length here. So I see that 16 is my shorter side, so I'm going to choose this side. 16 is to 20. And when we solve for x here, we're going to get x is equal to 12. You could also have set this up as x is to 15 and then use the longer sides. So as 19.2 is to 24. And you would also get x equals 12. You don't have to do both of them. But just remember, you need to be pulling the same from the same triangle. So x is to 15 goes like that, numerator, denominator, and then 16 is to 20. All right, and then I'm going to do one more here. For this one, we have the altitude situation. So we're going to say 10 is to 8, and then here they only give us those side lengths. So it's going to be x is to 14. And we're going to cross multiply, and we get 8x is equal to 140. X is equal to 17.5. All right, so I'd like for you to go ahead and do number 3 and 4 on your own. Pause the video, and then I will put the answer up. Okay, so here are the answers to 3. This one we have angle bisectors. So 32 is to 24, as 38 is to x. Solve for x. Here our altitude is just sitting outside of our triangle, which is fine. It's still an altitude. So we've got 12 is to 15, as x is to 42, and we solve for x. Okay, so then why don't you go ahead and do number 5. Pause the video. And then the answer we have is right here. Okay, so 20, again we have a median situation. 20 is to 12, and then we have this whole bottom right here. But we want to make sure that we're not grabbing the base of that triangle, which is what the x is here. So we want to get one of the sides. So this is 2x minus 9 over x minus 2. Okay, and then we have the triangle angle bisector theorem. So an angle bisector in a triangle separates the opposite sides into 2 segments that are proportional to the lengths of the other 2 sides. So what this means here is that AD over DC is equal to AB over BC. So we've got the angle bisector. It's separating this opposite side into 2 segments, which are AD over DC, and they're proportional to the lengths of these other 2 sides, AB over BC. Alright, so let's look at a problem. If Kn represents an angle bisector, solve for x. So I've got my angle bisector, so that means that 4.8 is to x, as, and then I'm going to grab the 12, is to 18. And again, just make sure the 4.8 goes with this half right here, so you want the 12 in the numerator just like the 4.8. You get 12x is equal to 86.4, x is equal to 7.2. Okay, why don't you go ahead and finish 7, 8, 9, and 10. Pause the video, and then we can look through the answers after you're done. Okay, number 7 is pretty straightforward. Number 8, here you just had to solve in put some missing information. If the whole thing is 39, that's 15, that's 24. So you've got 15 is to 24 as x is to 36. I think it's kind of helpful to trace it with your finger as you go. Solve for x. Over here, if this whole thing is x, and that's 12, then we're going to call this little segment here x minus 12. So 12 is to x minus 12 as 18 is to 30. And then the last one, we had to fill in some missing information as well. So this is 45, that's 27, 45 minus 27 is 18. So we have 27 is to 18 is 3x minus 9 is to x plus 11. Alright, and that's it for the notes. So your homework then will be homework number 5, and you're to do all of those problems, and you can work on those in class right now to try and complete them.